Hello friends. Friends, today we will discuss the concept of liquid pressure. We have discussed about what is pressure, that is force by area. But is there any pressure exerted by liquids? Yes, the pressure exerted by a stationary liquid, and that stationary liquid is, suppose it's kept in a container, in a glass tube, in a plastic container. At any point inside the liquid is known as liquid pressure, is known as liquid pressure, or it is known as hydrostatic pressure. Hydro means liquid, static means rest. Okay, hydro is from the liquid and static means at rest. Okay, that is a liquid in the state of rest. Exerted pressure is known as the liquid pressure. Okay, now liquid pressure has different properties. Okay, we will try to understand the first property with the help of an activity that you can do at your home, and I will also do it at my place and share a link with you very soon. Okay, now take a transparent glass tube. Okay, take a transparent glass tube, and suppose the length of the tube is around 30 centimeter, and the diameter is about 5 to 8 centimeters. Okay, and also take a good quality balloon. Good quality balloon. First is take a glass tube, and then take a, this is a glass tube, and then take a good quality balloon. Stretch this balloon at the and tightly at this end of the tube. Stretch this glass this balloon tightly over one end of the this tube. Okay, now you can hold the pipe at the hold this tube at the middle and keeping in a vertical position, and then pour some water in the pipe. Then pour some water in the pipe. Okay, does the balloon bulge out? Does the balloon bulge out? Okay, now suppose here the height is 1 centimeter, and this is the bulging of this balloon. Okay, now again pour more water. Again pour more water. For example, at a height of 2 centimeter. Now again note down this bulging. Now the bulging will be more. Now the bulging of the rubber tube will be more. Okay, so what does it shows? It shows that the pressure exerted by a water at the bottom of the container depends on the height of this column. Depends upon the height of this column. The pressure exerted by the liquid at the bottom of the container depends upon the height of the column. Okay, there is another experiment to do it. Now suppose you have a glass tube. You have a glass tube, and if you will do 4 holes, one here, second here, third here, and suppose 3 holes. Okay, and cover this hole with a tape, then pour water in this container, then remove the tape. What will you observe? You will observe that water will come out of this container like this. So the lower the hole means there is more pressure, there is more depth at this point. There is more depth, so there is more pressure at this point, and therefore water will go far away from this, from the water coming out from this hole. Okay, so again it proves that water pressure depends upon the height of the column. If you will change the type of the liquid, suppose if it was a water, now if you suppose you add some oil, vegetable oil, then of course this concept will be there. Now this depth, this distance may change, but concept will remain same. So it means it depends upon the density, of the liquid. So liquid pressure at any point depends upon the density of the liquid, and the second point is height of the liquid column, So two properties. The third one, two property means height, depends upon the height, and second one is depends upon the density. Third one, again take a bottle, suppose a soft drink bottle. Okay, and if you will make a hole here and then insert a tube, and it is filled with a water. Okay, insert a very narrow tube, then insert a balloon here. What will you observe? The balloon will bulge out. Okay, why this bulge this time? Because here the pressure by the liquid is at the walls of the container, and this wall of the container transmit this pressure to this balloon. Okay, so second is a liquid exerts pressure on the walls of the container, This was our third property. The fourth one, okay, the fourth one is again take a empty plastic bottle. Okay, a plastic bottle or a tin can. Okay, take a bottle, a can. Okay, now make hole at equal height from both sides, and then insert a liquid. What will you observe? Okay, do the different streams of water coming out the holes fall at the same distance from the bottle? Yes, at the same distance, from the bottle. Okay, so third one is liquid exert equal pressure. At the same depth or height. Okay, so we will revise it again. So first thing is the liquid pressure depends upon the height of the liquid column. Liquid pressure depends upon the density of the liquid. Okay, it depends on the liquid pressure exert pressure on the walls of the container. And fourth one is equal pressure at the same depth or height. It exerts equal pressure at the same depth or height. Okay, so this is all about the concept of liquid pressure. If you have any doubt, please share in the comment section. Thank you. Thanks a lot.